Okay, so I'm going to talk about Amazonian black earths. They're an archaeological kind of site in the Amazon. So for years I've been working in the Amazon. I read a book called 1491. Anyone here read it? So, archaeologists, okay. You all should read it. It's basically about life in the New World before Columbus came. Fascinating. So one of the big questions is, how many people lived in the Amazon before Columbus impacted it? So here's Amazonia, the Cerrado, the savanna next to it. So a lot's happening in the Amazon: deforestation, clearing for pasteurization, for ranching and logging. Those are things that I normally study, but I thought it'd be interesting if I started to look at these Amazonian black earths. So in the Amazon, it's an old seabed. There's little stone, as you know, in wet, humid tropics. Bone and wood decay quickly. So the only thing that's around are these kind of terra pretas, or Amazonian black earths. They basically are anthrosols that have high levels of nutrients, charcoal, pottery, and bones. So they're really rich in nutrients, very different than the sandy, nutrient-depleted soils throughout Amazonia. So the idea was, could we measure these from space? Okay, so could we tell a difference between where terra preta is, looking at the vegetation that grows on it? So we did a geodatabase of about 800 known terra preta sites across the Amazon. So if you figure that this is continental scale, this is about maybe 1,000 kilometers, this is where Manaus is, seagoing vessels can go all the way up there. Looking across the Tapajos here, you cannot see the other side of the river. Huge river. So basically, we went through, found where all the terra preta sites were. We filtered them. So from about 800, we went down to about 250 where we were sure of their location. They were in intact forests, because a lot of this land has been cleared. A lot of this black area has been converted to pasture. So we used a satellite called MODIS. MODIS has 2 satellites in its kind of orbital platform. It images the entire world every day, twice daily. We use a composite of every 8 days to get rid of clouds. And basically, let's just zoom. Actually, we'll go back up. What we were finding is we thought that you're looking at NDVI and the land surface water index. This is basically how green the forest is. We thought the terra preta would be greener. It would be healthier. It would do better in droughts. And what we found is that the terra preta was browner. It had less water in the vegetation. And so it was a lot different than what we thought would be growing on these nutrient-rich soils. So this was the exact opposite of what we thought. Here's a picture of the Lotus Imagery. This is NDVI across the whole basin. So we had this as a monthly estimate for 15 years. Here's a close-up of kind of brightness. This is like a photosynthetic index. You can see that the terra preta, which are the triangles, are lower and much lower during a drought period. So 2005 was a drought and 2010 was a drought. And so we use those to kind of tease out information about where terra preta could be. So we used a geospatial technology called maximum entropy modeling. Basically, it's derived from what kind of ecologists use to determine where species presence are. So as a birder, if you look across the landscape and you do your bird surveys, you only know where the birds are. You really don't sample where the birds aren't. And that's a lot like archaeology. You only know where the archaeological sites are. Rarely do you have a good survey and it's reported where sites aren't. So basically, we use this kind of habitat prediction model for predicting where terra preta should be across the Amazon. What we found was it's in this side of the Amazon. It tends to be along the rivers. And this is really interesting. And it's really different than what people said. There's one school of thought that says there's lots of people that live in the Amazon. There's one school of thought that said nobody lived in the Amazon. What we found is it's in between. There were some areas that were highly impacted. There were some areas that were not impacted. And so these areas along the river were where we predicted terra preta to be. When we used some other kind of forest properties, we compared tree height and biomass in what was terra preta and what is not terra preta. And we found that terra preta had shorter trees and had less biomass. So these forests, we believe, were impacted 500 years ago by indigenous people and haven't regrown in 500 years. In addition, these people picked out some of these sites because they were easy to clear. If we go back here and we see that it's in the eastern Amazon, this area tends to be really dry and it's a lot easier to burn and clear. So if anyone's ever tried to cut down a tree with an axe, it's hard. Now imagine a stone axe, it's nearly impossible, especially a 1.5 meter diameter tree. And so what we found was that these forests are drastically different between the western and eastern Amazon. We were able to detect these differences using a satellite across the Amazon, and what we're further looking into is other geospatial aspects of these terra preta across the landscape.